Containerization is a lightweight form of virtualization that allows developers to package applications and their dependencies into a single portable unit called a container. Unlike traditional virtual machines, containers share the host system's kernel, making them more efficient and faster to start. This technology has revolutionized the way applications are developed, tested, and deployed, providing consistency across multiple environments. Containers offer several advantages over traditional deployment methods. They ensure consistency across development, testing, and production environments, reducing the "it works on my machine" problem. Containers are also lightweight and start quickly, making them ideal for microservices architectures. Additionally, they provide better resource utilization and isolation, enhancing security and performance. Docker is the most widely used platform for containerization. It provides tools and services to create, deploy, and manage containers. Docker images are the blueprints for containers, containing everything needed to run an application. Docker Hub is a repository where developers can share and access Docker images. Docker Compose allows for defining and running multi-container Docker applications, simplifying the orchestration of complex environments. Azure Container Instances, ACI, is a service that allows you to run containers without managing the underlying infrastructure. ACI is ideal for scenarios where you need to quickly deploy and scale containers without the overhead of managing a Kubernetes cluster. It supports both Linux and Windows containers and integrates seamlessly with other Azure services, providing a flexible and cost-effective solution for running containerized applications. Azure Kubernetes Service, AKS, is a managed Kubernetes service that simplifies the deployment, management, and operations of Kubernetes clusters. AKS provides features like automated upgrades, monitoring, and scaling, making it easier to manage containerized applications. It integrates with Azure DevOps for CI/CD pipelines and supports advanced networking, security, and governance features, making it suitable for enterprise-grade applications. Building Docker images involves creating a Docker file, which is a script containing instructions on how to build the image. The Docker file specifies the base image, application code, dependencies, and any other configurations needed. Once the Docker file is ready, the Docker build command is used to create the image. This image can then be pushed to a container registry like Docker Hub or Azure Container Registry for distribution. Deploying containers to Azure Container Instances, ACI, is straightforward. First, you need to create a container image and push it to a container registry. Then, you can use the Azure CLI or Azure portal to create a container instance, specifying the image and any necessary configurations like environment variables, ports, and resource limits. ACI handles the rest, provisioning the necessary resources and running the container. Deploying containers to Azure Kubernetes Service, AKS, involves several steps. First, you need to create a Kubernetes cluster using the Azure CLI or Azure portal. Next, you create Kubernetes manifests, YAML files, that define the desired state of your application, including deployments, services, and configurations. Finally, you use kubectl to apply these manifests to the cluster, which schedules and manages the containers according to the specified configurations. Scaling containerized applications can be done both horizontally and vertically. Horizontal scaling involves adding more container instances to handle increased load, while vertical scaling involves allocating more resources, CPU, memory, to existing containers. Azure Kubernetes Service, AKS, supports both types of scaling through features like the horizontal pod autoscaler and vertical pod autoscaler, allowing applications to dynamically adjust to changing demands. Monitoring and logging are crucial for maintaining the health and performance of containerized applications. Azure provides several tools for this purpose, including Azure Monitor, which offers metrics, logs, and alerts for your containers. Azure Log Analytics can be used to collect and analyze log data, providing insights into application performance and issues. Integration with Prometheus and Grafana is also supported for advanced monitoring and visualization. Security is a critical aspect of containerized applications. Best practices include using minimal base images to reduce the attack surface, regularly scanning images for vulnerabilities, and applying the principle of least privilege. Azure provides several security features, such as Azure Security Center, which offers threat detection and recommendations, and Azure Policy, which helps enforce compliance and governance policies across your containerized environments. Continuous integration and continuous deployment, CI/CD, are essential for the agile development of containerized applications. Azure DevOps provides a comprehensive suite of tools for setting up CI/CD pipelines. You can automate the building, testing, and deployment of Docker images using Azure pipelines. Integration with Azure Container Registry and Kubernetes Service, AKS, allows for seamless deployment and scaling of your applications. Consider an e-commerce platform that needs to handle high traffic during sales events. By containerizing the application and deploying it on Azure Kubernetes Service, AKS, the platform can easily scale to meet demand. Using Azure DevOps for CI/CD ensures that new features and bug fixes are quickly deployed. Monitoring tools like Azure Monitor and Log Analytics help maintain performance and quickly resolve issues, providing a seamless shopping experience for customers. The future of containerization looks promising, with advancements in orchestration, security, and integration with cloud services. Emerging technologies like serverless containers and edge computing are expanding the possibilities for containerized applications. As organizations continue to adopt microservices architectures, the demand for efficient, scalable, and secure container solutions will only grow, making containerization a key component of modern application development. Implementing containerized solutions on Azure offers numerous benefits, including consistency, scalability, and efficiency. With services like Azure Container Instances, ACI, and Azure Kubernetes Service, AKS, developers can focus on building and deploying applications without worrying about the underlying infrastructure. By following best practices for security, monitoring, and CI/CD, organizations can ensure the successful deployment and operation of their containerized applications, paving the way for future innovations.